The same thing that makes this happen makes this happen. And this. It's electricity. Whoa.
7 seconds.
Bill Nye the Science Guy.
Brought to you by Electron, making your world a brighter place.
Hey, is your TV on? If it is, that's great. You're using electricity. But if you're watching the show and your TV's not on... Anyway, what is electricity? I mean, where does it come from? Is it just sitting in the wall waiting for us to use it? Or is it constantly spilling out of sockets and we don't notice it? And how can something so powerful be invisible? Well, electricity is the flow of tiny particles called electrons. And they're not just smaller than atoms, they're actually part of atoms. Take a look at this. It's our battery-powered electrical circuit of science. We're going to run this big light with this big battery. Watch.
Attention, Nylab.
See, right now, electrons can flow from this side of the battery, through this wire, through the switch, through this wire, into the light, and back to this side of the battery. They're flowing in a closed path, what scientists call an electrical circuit. Now, circuit, that's from an old word for go around. So electrons, right now, can go around an electrical circuit. The flow of electrons is a lot like the flow of water. No kidding. Watch. When I operate this great big water pump of science, water goes through this hose into this box and makes this water wheel go around. And it goes out the other side and through this hose back to the pump. It's a closed path for the flow of water. It's a water circuit. It's just like the flow of electrons through an electrical circuit. Electricity is a very versatile form of energy. The same electrons that are making the light up are making a motor go around. See, electricity can do all kinds of different jobs, and they're all done with electrons. So where does electricity come from, anyway? Well, in 1831, two scientists figured out how to make electricity. It was Michael Faraday, working in Britain, and Joseph Henry, working in the United States. At about the same time, they both did an experiment, something like this. Michael Faraday took a coil of wire, and he moved it over a magnet. And when he did, electricity started to flow in this coil. The electricity went down over here to another coil and made a compass needle move. Well, Michael Faraday was doing this experiment for an audience, and a woman came up to him afterwards and said, Mr. Faraday, of what use is it? And he said, Madam, will you tell me the use of a newborn child? And what he meant was, would you take a look? I mean, I'm moving the compass needle without touching it. You understand? I have a coil of wire way over here, and I'm making a compass needle move way over there with no apparent force. I mean, some force is going right through the air and wiggling that needle. Something's happening here. Some spectacular effect is happening here. You may not completely understand it right now with no apparent force. One day we will, and it's going to be a big deal. Thank you for joining me on... Consider the following. Electricity is the flow of electrons. Electrons are the tiny particles that buzz around the outside of atoms. Now, when electrons are able to jump from one atom to another, well, that's the flow of electricity. Now, in some materials, like metals, electrons can jump from atom to atom very easily. Atoms in metals are like a bunch of beehives. The electrons are like the bees buzzing around the hives. When electricity flows, it's like the bees jumping from hive to hive. That's electricity.